Hello everyone. On this video we will be looking at the conic section, the parabola. Alright, now the parabola is basically just a set of points that are the same distance from a line that we call the directrix and a point not on the line that we will call the focus. Alright, so let's say if we have our horizontal line here, and that line we will call our directrix. Alright, so let's say if we put a point here that we will call our focus. Okay, so let's say if we pick a point right in the middle, halfway between the focus and the directrix. Okay, same distance. Okay, and what if we pick a point here that once again is the same distance? And we pick a point here that once again is the same distance. What if we pick a point here that once again is the same distance? And you pick a point here that once again is the same distance. And we pick a point here that once again is the same distance. And you got to kind of use your imagination. I'm not measuring these lines, just kind of walking you through them. And we pick a point here that's the same distance. Okay, so that point is the same distance here and there, the same distance. Now, if we connect those lines or those points, we have our parabola. All right, so that's the general idea. Okay, so let's go ahead and look at how we're going to come up with our formula for the parabola. All right, so if you are still drawing this, feel free to press pause, but we're going to go ahead and move on to our next page. Okay, so we're going to let the letter P denote the distance between the vertex and the focus and the vertex and the directrix, which is basically, let me go back to the previous page for a second. So the vertex is this point right here, and P is going to denote the distance between the focus and the vertex and the directrix and the vertex. So both of those, since they're equal, will be denoted by the letter P. Okay, so just to kind of make things a little easier, okay, so for simplicity, we will let the focus of our parabola become the point 0p. Okay, so in other words, it's on the y-axis. And our directrix is y equals negative p. Okay, so if we draw that out, we have our y-axis and our x-axis. X and our y. And our focus is the point right here, 0p. And our vertex is here, right at 0, 0. And our directrix is y equals negative p. All right, so if you notice, you have your vertex here. So if you go up p number of units, you're at your focus. If you go down p number of units, you're at your directrix. All right, so let's say we pick another point, not just a vertex, but let's say we pick another point that's the equal distance right there. Okay, let's say we call that point xy. Okay, so it's just a point on our parabola. Okay, so we know the distance from the focus to this point is d1, and the distance from this point to the directrix, we'll call that d2. All right, so first thing we're going to do is we want to find out what that d1 and d2 is equal to. Okay, so using the distance formula, where it's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, but the thing is, both distances are equal. That means that d1 is equal to d2. All right, so if we use the distance formula on both sides, our distance 1 from the focus to our point xy, we have our x2 minus x1. So if d1 equals d2, then that means that the square root of x2 minus x1 is x minus 0 squared plus y minus p squared equals our distance 2, which this point here is the same distance, it's just vertical, so this is x and negative p. Okay, so you have x minus x squared plus y minus negative p squared. Move this up. Okay, so of course that cancels out. X minus x is 0. So we end up with x minus 0 is just x squared. X squared plus y minus p squared is equal to the square root of y plus p squared. All right, so we're going to go ahead and square both sides. Let me move this over. So if we square both sides, then of course the square and the square root cancel each other out. So we end up with x squared plus y minus p squared equals y plus p squared, because this square and square root cancel each other out. So if we go ahead and expand both of them, we have x squared plus, if we make this y minus p times y minus p, we'll end up with y squared minus 2py plus p squared equals, if we make this y plus p times y plus p, we have y squared plus 2py, plus p squared. All right. Now, if you notice, if you subtract y squared from both sides, this disappears and this disappears. If you subtract p squared from both sides, this disappears and this disappears. Okay. So we end up with x squared minus 2py equals 2py. So if we add 2py to both sides, we have x squared equals 4py. And that formula is a parabola whose vertex is at the origin and focus is the point 0p. Now, if our focus became 0, negative p, if the focus is negative, well, if p is negative, not the focus, if p is negative, the parabola will open downward. Just a little side note here. But this p is positive, so we'll open upward. All right, so if you are still writing, of course, feel free to press pause, but we're going to go ahead and move on to the next page. Okay. Now, if we replace x with y and vice versa, replace y with x, it reflects a graph about the x-axis. Okay, so in other words, if we take our previous formula, x squared equals 4py, we know that it looks like this. But if we swap out the y and the x, y squared equals 4px, our graph will look like, well, in this form, it looks like this or this, depending on if p is positive or negative. But in this case, our graph will look like this or this. Okay, so that means if we have, let me just draw a graph here. And we have our x and our y axis. Okay. So if we draw our directrix, instead of y equals negative p, we make it x equals negative p for our directrix. And it's centered at the origin. And our focus in this case would be p0. So if you have y squared equals 4px, then that is a parabola with a vertex 0, 0, the directrix, oops, don't really need that, x equals negative p, and a focus at the point p0. Now in this case, if the p is negative, the parabola opens to the left. Right? Now, in general, let's say if we want to get our, I'm just going to go back to the previous page for a quick second. Let's say if we want to get that graph and we want to shift it up, down, left, or right. And that means for x squared equals 4py, let's shift our graph h units horizontally and k units vertically. Okay, so that means our x will become x minus h, and our y will become y minus k. Okay, which means our vertex will be the hk point, because that's where we're shifting it. All right, so just knowing this will give us our standard form of the horizontal parabola. All right, so if you're still writing, feel free to press pause, but we're now going to look at the general formula. All right, so I have this already written up. Okay, so we have our horizontal parabola and we have our vertical parabola. So again, if we shifted it h units horizontally and k units vertically, our vertex will be the point hk. Okay, so we know that if our p is greater than 0, it opens upwards. If our p is less than 0, it opens downwards. Our general formula, remember, it was x squared equals 4py when it's vertical. It's now x minus h squared equals 4py minus k. Okay, to find our focus, it was going to equal h k plus p. Okay, now to find our directrix is going to be y equals k minus p, and that's covering up for any shift in the graph. Okay, and p is going to equal our sine distance from the vertex to the center. Okay, and also the vertex to the directrix. Okay, so it's going to be either positive or negative. All right, now for your horizontal, I'm going to move this back up in 1 second. If p is greater than 0 for the horizontal graph, it opens up to the right. If p is less than 0, it opens up to the left. Now the general formula for our horizontal parabola, cover that up, is y minus k squared equals 4p x minus h. Remember, if it's centered at the origin, it's just y squared equals 4px. But if the graph shifts, it shifts either k units vertically or h units horizontally. But if it's centered at the origin, h and k will be 0, 0, so you'll still end up with y squared equals 4px. This is just the general formula. Okay, so to find the focus of the horizontal parabola, it's going to be h plus p k. To find the directrix, is going to be x equals h minus p. And the vertex for both is always the point hk. All right, so if you are still writing, by all means, feel free to press pause. But that is it for this one. If you look at the second part of the parabola video, we will go through all of our examples using this very page right here. Okay, so hopefully this made sense, and I will see you on the next video.